Welcome back again, class. Today we are going to move on to graphing logarithmic functions. So yesterday we started talking about the very basics, how they are the inverse to exponential functions. What I hope you remember, way back in chapter 6, when we talked about graphing inverse functions, I want you to remember they create a reflection across that line, y equals x. So notice what's happening here. All right? Notice our graphs are exact mirror images of each other because again, that's what it takes to be a true inverse. They have to mirror each other. Now, what that means is some other aspects of them mirror too. So you know exponential functions had a horizontal asymptote at y equals 0. Well, now we take that horizontal asymptote and that gets flipped as well. So now instead of having a horizontal asymptote, we're going to have a vertical asymptote. And again, I'll show you more about that, you what that means. But I just wanted to give you a general idea what these graphs will look like. So when we start graphing them, you won't be shocked with the shape that you're getting. Now, graphing them by hand is going to be a little bit different than what we've done before. You're used to picking x's and then using those to get your y value. We are actually going to do the reverse. We're going to pick y values and solve for x. So here is my beginning problem. Y equals log 3 of x. Now, we don't know how to graph those. However, we do know how to graph exponential things. So what I'm going to do is I'm going to take 3 to the y and set that equal to x. I'm going to convert it into exponential form because now I know how to find points and how to graph that. So the key here is I'm going to switch its form, all right? I'm going to switch it. So it's still exactly the same graph, okay? I'm just writing it in its other form because that is going to be easier for me to find values for. Because if I start picking y values, I know what the x value is then. So that's kind of the key here. We're going to be doing these a little bit backwards. We're going to rewrite it in its alternative form, in its exponential form. And now I'm going to choose y's and use those to calculate the x's. So if I have 3 to the negative 2, again, I've chosen a y and I'm using that to get my x. 3 to the negative 2, type it in the calculator, will give you 0.11. 3 to the negative 1 will give you 0.33. 3 to the 0 will give you 1. 3 to the 1 will give you 3. 3 squared will give you 9. And that is how I fill in my table. So I've got my table. Now the next thing, I'm going to draw my vertical asymptote right away. All right, so when there's no shifting, no anything, my vertical asymptote is going to be right there at x equals 0. And now I can plot my points. So I have my x's and I have my y's. So 0.11, negative 2 will put me right there. 0.33, negative 1, 1, 0, 3, 1, and 9, 2. And it wants me to connect my points, so I'm going to connect them. And again, this will follow that asymptote forever. All right, that's the point of drawing the asymptote, so you can see where your graph is going. So that's why you absolutely have to graph those asymptotes, so you can see where your graph is ending up. So there's a general shape of my logarithm. So let's talk about the domain, range, and the y-intercept. So here, domain. For the domain, what x values am I using? Well, I put my vertical asymptote at 0, so I can't actually use 0, but my x's are everywhere above that 0. So I'm going to say my x's are strictly greater than 0. Range, that's going to be my easy one. Range is going to be all real numbers. Now notice this is different than exponential. That's flipping from my exponential. All right? This time it's my range that can be anything. All right? My range can be anything, all real numbers. My x's are restricted to being above that vertical asymptote. And my y-intercept, where does it cross the y-axis? Well, you may notice if there's that asymptote there, it actually won't. It's never going to touch the y-axis. So this is a unique graph where there actually is no y-intercept. It's not going to touch it. All right, so there's our first graph. Now, before I move on, please make sure you have that sketched down because we're going to use these exact same skills to do our next one. So here's our next one. And what we want to do, first thing, we want to write it in its alternative form. So I'm going to take this and say 4 to the y equals x. Okay? We have to be able to write it in that alternative form. It is an absolute must. All right? Because this I know how to work with. So now remember, we are choosing our y values. We're choosing our y's to calculate the x's because I can say, hey, 4 to the negative 2, I can type that into my calculator and get 0.0625. 4 to the negative 1, I can type that into my calculator and get 0.25. I can type 4 to the 0 in and get 1. 4 to the 1 and get 4. 4 squared and get 16. So again, that's why we change it to its exponential form. It's the same equation, but it's easier to plot. It's easier to find these values to construct my table. You just have to remember that you're basing it on y values this time. First time we've ever done that. So I'm going to put in my vertical asymptote at 0. And now I'm going to start plotting my points. So 0.0625, so barely off the y-axis, and negative 2. So literally sitting right there. 0.25, negative 1, 1, 0, 4, 1, and then my last point is going to be off my graph actually. So I'm going to take these, and again, I plot that my asymptote, so I know it is following that asymptote forever. And let's take a look at what happened. So my domain, well, my domain is actually exactly the same. I look to that vertical asymptote, which is sitting at 0. And I see all my x values being strictly greater than that 0. This time my range is the easy one. I can use any y value. I can plug in any y value to this. So we're going to say that the range is, again, all real numbers. I can choose anything for y. All right, so that's another one of my basic cases, all right? I wanted you to see two of those just so you get comfortable with that basic case before we start transforming it. Because just like every other function when we graphed, these follow the same set of transformation rules. So I'm not going to go through this whole little nitpicky table because, again, it's things that you already know. You've seen this countless times in chapters 2, 4, 5, 6, and 7, actually. Every chapter since chapter 2, you've come across this. So let's take a look at a slightly more complicated function. Let's look at that. So thinking of a parent function, all right? Because again, whenever we have translations and transformations, we're talking about parent functions. So this is going to be my starting point. That is my parent function. All right? So notice when I put this in its alternative form, 4 to the y equals x, haven't I already calculated that? Isn't that the problem we just did? So for this one, I'm not making you remake this whole table because guess what? You've already made the table of that one. So all I'm going to start you off doing is actually plotting those points. So these points from up here that we already discovered, I'm going to just replot those points, all right? So we have 0, or sorry, not 0, 0.0625, -2. Then we have 0.25, -1, 0, 1, 4, or sorry, 1, 0, 4, 1, and then the other we can't see. And we want to think about this transformation. We want to think about what is happening to this function. So I take every one of those points, and I'm going to say they are shifted 3 to the right and 4 up. All right, remember the x's always do the opposite of what we want to expect. But we need 3 to the right and 4 up. So I'm going to do that to every one of my points. 3 to the right, 4 up. 3 to the right, 4 up. 3, oh, I did that one. 3 to the right, 4 up. 3 to the right, 4 up. Now, my asymptote is going to follow that exact same shift, that same movement. So my asymptote is actually going to move 3 to the right as well. So I want you to plot that shifted asymptote because again, then you know where your graph is going off to infinity. So, and again, just like with exponential where it shifted up and down, this time it shifts right and left because it is sitting vertically. And now I connect my points. And there is my general shape for my logarithm. And if we want to have the conversation about domain and range, well, this time I see my vertical asymptote at 3, and I see my x's being everywhere above that. So again, you always look to the asymptote to see where your domain starts. All right, and then you see, is it greater than that number or less than that number? And the range, super easy, all real numbers for the range. All right, we're almost there. So let's take a look at a stretch. All right, so here we have 5 log base 2 of x. So again, what am I doing? Well, I take the parent function. Well, the parent function is just log base 2 of x. I put that in its alternative form, in its exponential form. 2 to the y equals x. And I start picking values. I start choosing values. Well, I'm going to choose 0, 1, and 2 for this, okay? And again, you're picking y's and plugging those in. So 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. And what am I doing? Well, that times 5, we're still multiplying the y by 5. So remember, I always make that third column to show that stretch in my table. Well, the thing to keep in mind here, that stretch is still influencing my y values. So it is those y values that get multiplied by 5. All right? So do be careful about that. Okay? Even though we're doing this a little bit backwards, that multiplier, it still affects the y's. All right? So multiply those y values by 2, or by 5, sorry. And now I'm going to ignore that middle column. I'm going to ignore that column so I can see my x's and my new y values. All right? So 1, 0, 2, 1, 2, 5, 2, 3, 4, 5, and 4, 1, 2, 3, 4, 10. All right. So next, I need to plot that vertical asymptote. Well, here, there was no shifting, so I don't have to worry about that. My vertical asymptote will not be shifting. And now, I just plot my points. Now this one, because it's so stretched, it's difficult to see kind of that logarithmic shape, but that's why we draw the asymptote, so you still have an idea where it's going, all right? If you don't graph that asymptote, you're not going to get full points for these problems. All right, so just some key things to remember. Vertical asymptote, it will move with the horizontal change, just like the domain will move with that horizontal change. And I want you to remember that the range is always all real numbers. You can pick any y value to use in this case. Alrighty, so there you have it, all the graphing for these logarithms that you're going to have to do and know. So thank you for joining me. Make sure you have all of this written down, please, and then come back to class prepared to do your practice work.